video displays. So in here, we're going to talk about monitors, we're going to talk about resolution, and we're going to talk about doing extending and cloning our desktops. So for the A+ exam, there's a couple of different types of monitors you have to be familiar with. The first one is called a CRT. Now, if you run into a CRT at work, you should immediately put in a purchase order to get a new LCD or LED, the LED one, because they suck, right? They're harder on your eyes. They're really old. I don't know many people who have used them past the year 2002. But again, we still need to know what they are. CRT stands for cathode ray tube. Okay. It's older. You'll still find it in some offices because older offices, they don't want to spend money to buy new stuff if they don't have to. So if it's still working, why not keep using it, right? They're very large and very heavy when they get large in size. So if you have a 36-inch CRT, it can be 100 to 150 pounds. If you have a 36-inch LCD, it may be 15 or 20 pounds, right? So these things are very heavy. So again, that whole lift with your legs, not with your back, becomes important when lugging these around. They're analog. So they're not digital, so they're very limited in resolution. Even if you have a very large one, the resolution on these is not going to be very high. Dot pitch is how we measure these, the quality of them. So if you have something like a 0.28 millimeter or less, that's good. And what we're talking about there is these images are actually made up by a series of dots on the screen. And each of these dots, the size of the dot makes it less or more blurry. If you have a large dot pitch like 0.36, that means the dot is bigger. It's going to look blurrier on the screen. If you have a smaller dot pitch like 0.28 or 0.24, it will be much more tiny dots, makes it a clearer image. So you want a smaller number there. And your refresh rate is important as well. So what these things do is they work like an old style TV. They make up the image using dots, and they're constantly refreshing that image by putting those dots over again. And so if you have a very low refresh rate, it's not refreshing as often. It's going to be more blurry. It's going to be more straining on your eyes. If you have usually the minimum is a 60 hertz. If you can get up to about 75 hertz, which means 75 times per second, it refreshes that image. Your eye gets less strain on it. And so this was a problem for people when they worked in office environments and they were on these computers for 8 or 10 hours a day. They were getting a lot of eye strain using these CRTs. You don't have this problem with the LCDs or the LEDs. They work a lot nicer, a lot better, which is why we've all moved towards that. And again, remember, CRTs, they have these capacitors in here. You don't want to take them apart. They have high voltage. They can hurt you. And again, you have to dispose of them properly depending on your environmental regulations. You're really not going to run into these very often unless somebody's asking for you to change it out or dispose of it. At least that's my experience. LCDs. So LCDs are liquid crystal displays, and they actually light up using a cold cathode ray fluorescent lamp, a CCFL, which kind of looks like those curly Q lamps you buy now. The light bulbs that look like curly cubes, you know what I'm talking about. Those are CFLs, right? These are used a lot inside laptops, notebooks, laptops, and desktops. They started out in laptops and notebooks, and now pretty much we all use them for our desktops as well. We look around the room, we've got 20 of them sitting in here alone, right? They can either have an output as VGA, which would be analog, or they can output digitally as DVI-D if they're using that digital video interface format. They are thinner, they are lighter, they use less power, they generate less heat, and they take up less space than CRTs. You can wall mount them. They're really cool, right? They come in, the old style was a 4:3 format, which is a standard TV format. Now everything has pretty much gone widescreen, either 16:9 or 16:10 format. Ones on your desk are 16:9 format. Most laptops are 16:9 or 16:10. They do have a native resolution for LEDs, for LCDs. Everything else is scaled. So for instance, on my laptop, its resolution is 1280 by 768. And if I want to make it bigger or smaller, it's just going to scale up or scale down to match that. But that's what it's designed to operate at most efficiently. It's every LED you bought or LCD you buy is going to have a native resolution. And when you're operating it that way, it looks best. But if you go up or down, it will stretch or shrink to match that. LED, they work just like LCDs. The big difference here is we're not using the compact fluorescent to light the screen. We're using LEDs as our backlights. That's the only difference here. LEDs are actually a little bit more efficient. They use less energy as well and less heat. So that's the benefit of them over the LCDs. But other than that, they're fairly similar. Some people argue that the LEDs don't have as good of black levels as like a plasma and back and forth of that kind of stuff. But really, they're all fairly similar from a technology standpoint. Next one we have is plasma. We don't use this very often for computer screens, but we use them for HD TVs like a lot. And they have really dark darts and really white whites, and they got really good contrast on them. The reason why we talk about them is most people nowadays, especially gamers, like to hook up their computers to big TVs. Why use a 20-inch monitor? We can use a 56-inch TV, right? That's my opinion. And what they do with plasma is you're actually using ionized gas to lights up when it's charged with electricity. You can see that here in the picture. They give you great brightness, very low lows, very high highs, darker black than an LCD. But they do use more energy than LCDs. And they actually had sparked the invention of the LED backlit LCD monitors because people wanted this dark darts and lights that plasma was giving in a computer monitor. So that's why they went over to LEDs, which gave them that. So really what you're going to see in most desktop computing now is LED monitors. Most TVs are plasma or LED. LED has really taken off a lot. And the last type we have here that we're going to talk about, or second to last type, is projectors. The reason why I talk about this is because in business environments and schoolhouses, we use them a lot. You guys are looking at a projector right now. Isn't it beautiful? It's used to display a computer screen on a large surface like this wall or this blackboard. Traditionally, you can use it as a second monitor. You can either clone it or you can extend it. So in this case, we have it as a clone of my monitor up here so you guys can see what I see. It uses strong lamps to push images across the room, and they can get very hot. If you guys walk over to this projector in the break and put your hand up there, you'll feel a lot of heat coming out of it. And it uses fans to cool it off, but it is kind of noisy. So if you walk over to this fan, if you're sitting in the aisle seat, you can usually hear the fan. If you're sitting in the back corner, you can't. There's two different varieties that are popular, LCD ones and DLP ones. LCD ones, they use an LCD lamp to push the images at compact fluorescent light, right? And DLP uses a spinning wheel to reflect the light. And now it's really made popular by Texas Instruments and then improved upon by some others. But it gives a really nice quality image. Again, the big idea of the projector is you're going to be able to make a really big image across the room so everyone in the boardroom can see it, right? Yeah. And the last one we're going to talk about here is what's called OLED, which is this new type that you're not going to see in a computer for a while. It's a emerging technology. It's an organic light emitting diode. The idea here is that it uses semiconductor material between the electrodes to emit light. It's an emerging technology. It's expected to be a good replacement for LEDs in the future. It also is where people can make see-through screens, and they can use bendable screens using this OLED technology. It's pretty cool stuff. It's just not really cost-effective yet. Yeah, I do not know. I believe they're using organic matter to make it. Not organic as in non-pesticide, but organic as in living stuff. But I am not sure exactly. I have to look that up. So video display settings. So the display resolution is telling you how many pixels will be on a screen. And a pixel stands for a picture element, okay? So basically it's one little box out of your screen. So my laptop, for instance, I told you guys it has a 1280 resolution. So it means there's 1280 little boxes going across my screen. And going up and down, I have 768 boxes going up and down my screen. So in the old days, we had SVGA. And when I say old days, I'm talking like 1995 when gaming first started getting popular. An 800 by 600 was considered good quality, right? This is like when Doom and Wolfenstein first came out. And you'd have an 800 screen wide by 600 pixels tall. And then we got XGA, which went 1024 by 768, which is kind of the standard for a long time. And then we kept getting bigger and bigger and bigger. And over on the right, you'll see this big chart of all of the terms and all of their corresponding resolutions. So if somebody told you, hey, I have a 1080p, you can know, well, that's HDTV, that's 1280 by 1080. Or it's like 1920 by 1080. Or they said, I have an XGA, that's 1024 by 768. I rarely hear people talk about it in terms of those acronyms. Most of the time, we're just going to tell you the numbers that we're using, right? You can set that in Windows. If you right-click on your desktop and then go to Screen Resolution in Windows 7, it will bring up the dialog box you see in the bottom left corner. There's a slider where you'll slide it up and down to the amount of resolution you want. If you have more resolution, meaning you go to a bigger number, there's going to be more stuff fitting on the screen, but everything's going to look smaller. If you go to a lower resolution, like 800 by 600, it's going to fill the screen with bigger blocks, right? Because there's less blocks, they have to be bigger, and so things are going to look bigger. Another thing we can set is what we call the color quality. So way back in the old days, we used 4-bit color technology, which meant we had 16 whole colors to choose from for our games. It was amazing. And then they had this revolutionary breakthrough and they went to 8-bit in the mid-90s when Wolfenstein and Doom came out, right? And we could do 256 colors at a time. That was awesome, right? And the way we get 256 is it's 2 to the 8th power, which is 8 bits. Then they made it better and they went to 16-bit, which gave you about 65,000. Then now we went to what's considered mostly the standard, 24-bit, which is 16 million colors. That's pretty darn good, right? And for some people who like to really game, that's not good enough. So they went to 32-bit color, which gives them 4 billion colors to choose from. Okay. Honestly, your eyes are not going to really see the difference between 32-bit and 24-bit color, right? If you need 4.2 billion colors or 16.7 million colors, you're probably going to be pretty looking, there's only so many shades of gray, right? It's going to look about the same. But there is a huge difference when you go from 8-bit to 16-bit or 16-bit to 24-bit. So most of the time, if you want to save some memory, the more colors you use, if you go to 32-bit, you're going to be using more memory. So I'll set my machines at 24-bit. That's good enough. My eyes can't really see the difference past 24-bit anyway, and I save some memory. If you reboot your computer and it looks kind of old school, like this one in the upper left corner, that means you're in safe mode. Safe mode by default uses 8-bit, which is 256 colors. Safe mode we'll talk about later when we get into operating systems. It's where you go to fix problems when you have problems with the computer. But one of the ways you can determine that you're in safe mode is it will tell you in the 4 corners, it'll say safe mode. And the color scheme is going to be pretty bad. And again, you can change that from your display properties, as you see here in the bottom left. Just click on settings, and there you see it says true color 24-bit. If you go to drop it down, it'll go to 32-bit, or drop it up, this is 16-bit. And on this one, you have the resolution going left to right as well. This is an old Windows XP picture, just to give you an example. So we talk about refresh rates. With CRTs, refresh rate is very important. And it's measured in hertz, which is how many times it can cycle in a second. And how quickly your monitor redraws the screen is what we call the refresh rate. 60 hertz is fine if you're using an LCD or an LED, because LCDs don't refresh themselves. Once it's on the screen, it stays on the screen until the next picture comes up. But with CRTs, you want 75 hertz or more, otherwise you're going to cause eye strain. And again, you can change this from the settings. You go into monitor and it will select what the hertz is that you want to use. So which of the following panels allows for the thinnest possible display for the monitor? You guys think it's an LED, a DLP, a CRT, or a plasma? A, it's the LED, right? DLP, we talked about that's one of the spinning mirrors, right? You have spinning mirrors, you need space for that to happen. CRTs are the old school TV style, cathode ray tubes. And then plasma also has a thicker, heavier base than LED monitor. LEDs are very thin and very good for hanging on walls.